Old generation versus new generation. A journey through programming language generations. Programming languages have evolved tremendously since early 1950s, and this evolution has resulted in over 100 of different languages being invented and used in the industry. This revolution is needed as we can now instruct computers more easily and faster than ever before due to technological advancement in hardware with fast processors. The increase in quantities and speed powerful computers are being produced now, more capable of handling complex code from different languages from this generation like Prolog will prompt languages designers to design more efficient code for various applications. We start out with the first and second generation languages during the period of 1950-60, which to many experienced programmers will say are machines and assembly languages. Programming language history really began with the work of Charles Babbage in the early 19th century, who developed automated calculation for mathematical functions. Further development in early 1950 brought us machine language without interpreters and compilers to translate languages. Microcode is an example of the first generation language residing in the CPU written for doing multiplications or divisions. Computers then were programmed in binary notation that was very prone to errors. A simple algorithm resulted in lengthy code. Symbolic assembly code came next in the mid-1950s, the second generation of programming language like autocoder, SAP, and SPS. Symbolic address allowed programmers to represent memory locations, variables, and instructions with names. Programmers now had the flexibility not to change the address for new locations of variables whenever they were modified. This kind of program is still considered fast, and to program in machine language required high knowledge of the CPU and machine's instruction set. This also meant high hardware dependency and lack of portability. Assembly or machine code could not run on different machines. Throughout the early 1960s till 1980s saw the emergence of the third generation programming languages. Languages like Algol 58, 60 and 68, COBOL, Fortran, Era and C are examples of this and were considered as high-level languages. Most of these languages had compilers, and the advantage of this was speed. Independence was another factor as the languages were machine independent and could run on different machines. The advantage of high-level language include the support for ideas of abstraction so that programmers can concentrate on finding the solution to the program rapidly, rather than on low-level details of data representations. The comparative ease of use and learning, improved portability and simplified debugging modifications and maintenance led to reliability and lower software cost. These languages were mostly created following one Neumann construct, which had sequential procedural operations and code executed using branches and loops. Although the syntax between these languages were different, but they shared similar construct and were more readable by programmers and users compared to assembly languages. Some languages were improved over time and some were influenced by previous languages, taking the desired features thought to be good and discarding unwanted ones. New features were also added to the desired features to make the program language more powerful. All generation programming languages, Fortran and Algol. Fortran is a general-purpose procedural imperative programming language that is specially suited to numerical computation and scientific computing. Originally developed by IBM at their campus in South San Jose, California in the 1950s for scientific and engineering applications. Fortran came to dominate this area of programming early on and has been in continual use for over half a century in computationally intensive areas such as numeric weather prediction, finite element analysis, computational fluid dynamics, computational physics, and computational chemistry. This is one of the most popular languages in the area of high-performance computing and is the language used for programs that benchmark and rank the world's fast supercomputers. Fortran, a blend derived from the IBM mathematical formula translating system, encompasses a lineage of versions, each of which evolved to add extension to the language while usually retaining compatibility with previous versions. Successive versions have added support of the processing of character-based data. Array programming, modular programming, and object-oriented programming, and object-oriented and generic programming. The names of earlier versions of the language through Fortran 77 were conventionally spelled in all caps. The capitalization has been dropped in referring to newer version beginning with Fortran 90. The official language standard now refers to the language as Fortran, because the capitalization was never completely consistent in actual usage. Algol, short for algorithmic language, is a family of imperative computer programming language originally developed in the mid-1950s, which generally influenced many other languages and was the standard method for algorithm description used by the ACM. In the sense that most modern languages are Algol-like, it was argued the most successful of the four high-level programming languages with which it was roughly contemporary: Fortran, Lisp, and COBOL. It was designed to avoid some of the perceived problems with Fortran and eventually gave rise to many other programming languages, including BCPL, B, Pascal, Simula, and C. Algol introduced code blocks and the begin and end pairs for delimiting them, and it was also the first language implementing nested functions definition with lexical scope. Moreover, it was the first programming language which gave serious attention to formal language definition, and through the Algol 60 report introduced Backus norm form, a principal notation for language designing. There were three major specifications. Algol 58, originally proposed to be called for International Algorithmic Language. Algol 60, first implemented as X1, Algol 60 in mid-1960, revised 1963. Algol 68, revised 1973, introduced new elements including flexible array slices, parallelism, operator identification, and various features. Nicholas Wirth based his own Algol W on Algol 60 before developing Pascal. Algol W was intended to be the next generation Algol, but the Algol 68 commit decided on a design that was more complex and advanced rather than a clean specified Algol 60. The official Algol versions are named after the year they were first published. Algol 68, substantially different from Algol 60, but was not well received. So that is generally Algol means Algol 60 and delete therefore. Fragments of Algol-like syntax are sometimes still used as pseudocodes. New generation programming languages: C# and Java. C# is a multi-paradigm programming language encompassing strong typing, imperative, declarative, functional, generic, object-oriented, and component-oriented programming disciplines. It was developed by Microsoft within its .NET initiative and later approved as a standard by ECMA and ISO. C# is one of the programming languages designed for the common language infrastructure. C# language is intended to be a simple, modern, general-purpose, object-oriented programming language. The language and implementation therefore should provide support for software engineering principles such as strong type checking, array-bound checking, detection of pattern to use, uninitialized variable, and automatic garbage collections. Software durability and program productivity are important. The language is intended for use in developing software components suitable for deployment in distributed environments. Source code portability is very important, as is programmer portability, especially for those programmers already familiar with C and C++. Support for internationalization is very important. C# is intended to be suitable for writing applications for both hosted and embedded systems, ranging from the very large that use sophisticated operating systems down to the very small having dedicated functions. Although C# applications are intended to be economical with regard to memory and processing power requirements, the language was not intended to compete directly on performance and size with C or assembly languages. Java is a programming language originally developed by James Gosling at Sun Microsystems, which has since merged into Oracle Corporation and released in 1995 as a core component of Sun Microsystems' Java platform. The language derives much of its syntax from C and C++, but has a simple object model and fewer low-level facilities. Java applications are typically compiled to bytecode that can run on any Java virtual machine regardless of computer architecture. Java is a general-purpose, concurrent class-based object-oriented language that is specifically designed to have fewer implementation dependencies as possible. It is intended to let application developers write once, run anywhere, meaning that code that runs on one platform does not need to be recompiled to run on another. Java is concurrently one of the most popular programming languages in use, particularly for client-server web applications with a reported 10 million users. The original and reference implementation Java compilers, virtual machines, and class libraries were developed by Sun from 1995. As of May 2007, in compliance with the specification of the Java community process, Sun relicensed more of its Java technologies under the GNU General Public License. Others have also developed alternative implementation of these Sun technologies, such as the GNU Compiler for Java and GNU Class Path. Old generation language versus new generation. Programming languages are used for controlling the behavior of a machine like natural languages. Programming languages conform to rules for syntax and semantics. There are thousands of programming languages and new ones are created every year. Few languages ever become sufficiently popular that they are used by more than a few people, but professional programmers can easily use dozens of different languages during their career. When we compare old generation language with new generation language, we can identify many features which was not exist in old generation. Here there are some comparisons of the language generations. Old generation has a logical software structure which is aimed to fix logical structure to the language. This generation language has high-level language, which means they are closer to human language. And the other thing which existing in this language is dependability of the language is very less. When it comes to new generation language, it has many more differences rather than old generation language. This generation language is more program friendly and support for structured programming. The aim of this language is to improve the usability. Unlike the old generation, this language is closer to the machine language, means this is low-level language which is more machine dependable. In old generation programming languages do not have inbuilt functions. This is something called inefficient and use spaghetti codes as well. These kinds of programming languages are supported for one particular paradigm. Heavily use some inefficient statements like goto as control flow. But in new generation languages, it uses number of inbuilt functions to make language easy. The most important thing in this generation is introduction of interpretation. This generation consists efficient and hardware independent languages. These languages do not consist any inefficient statement such as goto and supports for multi-paradigm. In old generation languages has no transistor being used to compile low assembly but can do coding very fast and efficiently. In these languages, which is labeled under old generation, is specific to particular targeted computer. These languages can easily read, write and maintain as it is more close to the human language and used to build applications. In new generation, it has compilers inside the machines. But when it's going to write codes, it takes much more time. application which has developed during new generation languages can run using any platform. These languages used for advanced enterprise application which is evolved and complex. In old generation no longer needing to state the length of multi-character and cannot create objects, and the syntaxes which is used is different from the new generation. For statement termination uses semicolon and new line terminator, and to indicate command lines use letter C. When it comes to new generation language, it improved support for aggregated data types and expression concepts. These languages can create objects. Object is a single unit which keeps data and methods of manipulating the data. Unlike the old generation languages, it do not need letter C for indicate command line. It only needs backslash to indicate command lines and use semicolons to terminate the statement. Block comments are generally those that use a delimiter to indicate the beginning of a comment and another delimiter to indicate the end of a comment. In early days, most of these languages is intending to use for computing application imperative. Some languages specifically use for numerical computing applications, but new programming language intended to use any applications, businesses, client-side, general service side, web functional, generic imperative and reflective. The most important thing of using new language is by using these languages can do any task. This video is presented by Darshana Gimhara, M.M.M.Muthugala, C.H.Perera, M.Muthugala and D.G.Kolombage. Thank you.